All right. Hello, everyone. We're back in education. If anyone has something that they want to bring up or add to the agenda, otherwise, I have a few thoughts or on what we could review and kind of just take stock of the pieces that have been activated, and then I guess just think about what we want to keep working on. But what does anybody want to add to the agenda?
I've just got a brief follow-up. It's not much of a issue. I was going to check with a publisher at Springer with regard to additional material from the first book, the principles book, and that guy is gone. So I've got to establish some new links with the people at Springer. So that's all I had to report back on.
Is there anything that we can help with, or do you see it as related to any ISSS works?
Well, not for the time being. It's just a matter of making connections with finding out who the new person is that's taken over that job, and then just reestablishing a link there. So that's just investigation on my part.
And what would be like the best outcome if you connect with the right person?
Well, the outcome would be what we had discussed before, that Chingai is interested in, is supplementary material linked from the website for the book, like his blog and things of that nature.
Sounds good. Shingai, any updates from your posts? I know there was this recent one.
Yeah, no major updates. This was my first time sort of writing about a specific real world topic. So took 1 week off from covering the principles and tried to do something a bit more applied. And it felt good to do something a bit more personal, a bit more practical. And got like a small but positive response so far. And I think it has, sort of kickstarted the part of me that actually does want to engage with these LLMs and use them to accomplish goals for myself. So yeah. Yeah, I think it's a bit of a tangent, but one project I would love to take on is George, you have a lot of ideas in your second textbook about building a systems knowledge base. And I'm wondering if I can use ChatGPT as a coding tutor and assistant to start implementing some of these ideas in Python code that I could actually use. So that's kind of like one long-term project that I'm interested in.
Well, yeah, I mean, you're free to do anything, explore anything. I just put that out there as a sort of a skeleton idea for how one would go about it.
Yeah.
Using as I showed in the book, you can use a relational database system to do that, but there are probably better options in the so-called network database systems now that exist that I didn't know about or have sufficient background in when I wrote that material. So that's why it ended up as relational database. But I think there are many more efficient options today. It would still have that same structure, I think, but just implemented as a network as opposed to it's a very artificial network the way I've got it set up now. And a lot of cross links that that have to be managed, that probably would be in the background in a network database system.
Yeah, are you talking about things like graph databases? I feel like GraphQL is one that I've heard of, that sort of thing.
Yeah, actually, graph is probably the more appropriate term.
Okay, very cool. Yeah, I mean, in the book, when you describe a simple graphical user interface that would allow people to play with these different systems building blocks, my mind, I very much want something like that. So we'll see if ChatGPT can help me get to building something like that.
Well, it'd be very interesting. It'd be an interesting project. Yeah, there are a lot of modules involved in that. One is the graphic front end, where you take all those icons and you can have a menu of all those icons and then drag and drop kind of approach. Those are the ones I'm familiar with from days gone by. So there might be other ways now that I'm just not familiar with. But the idea is ultimately to be able to show a system in those block diagram ways, using all those icons. And then hopefully when the simulation is running in the background, have that simulation update the graphical front end, and actually you can see things happening in that in the system as things are flowing through pipes and things like that.
Yeah, I could see that being really powerful, especially I think the use case that stands out to me is for like organizations, businesses that want a sort of real-time simulation model view into how their operations are going.
Yeah, I think it has a wide range of uses, including the sciences in general.
Yeah,
where visualization has become an incredibly important tool.
It also reminds me a lot of CAD.
Yes.
I wonder if we could work on the reference implementation of CAD, and it's like they've connected it to the formalisms of GDS, generalized dynamical systems, and category theory increasingly. So if we can start to sketch something out with CAD blocks and kind of use CAD on just starting with replicating what George had laid out, that could be very fun.
Yeah, that can be really cool. I definitely looking at George's proposed idea makes me think of CAD, and I think my experience with CAD was that it's really fun, it's a really cool tool, and if it had some sort of simple graphical user interface that allowed people to implement the block diagrams, it would be even more powerful. So yeah, I would love to explore this.
And for the systems knowledge base, do you mean, is this referring to knowledge about one given system in terms of the simulation for it, or like more on the knowledge engineering side, like how are we going to bring together different resources about systems science?
More so yeah, go ahead.
Oh, I was just going to say, I think it's all of both, in the sense that it's an engineering, it's a systems engineering approach to constructing knowledge that is retrievable and usable as it's discovered through the process of analysis. So it could be a specific system or it could be a generalized system. Like one of the models that I have in the end of the book, the complex, adaptive, and evolvable system archetypes, things of that nature. And so basically the idea behind it is really, again, it's what is likely to be I would say my hypothesis is that's how we'll find the brain actually represents knowledge in neural networks, and is able to retrieve and use it as a result of that. But that's a much more expanded conjecture.
Well, Shingai, if you're gonna work in this direction, then I think it could be very cool and would be fun to develop it. And it is super fun to like put in existing examples of the code and the documentation for some of the functions, and then just see how far we can get. And yeah, it fuses very well with LLM discussion and you know, the knowledge engineering.
Absolutely, absolutely. Another thing that did come up for me as I was researching that post, there's a systems engineer at the University of Virginia who he uses systems theory in his engineering work. So he wrote this paper where he was describing a hydraulic actuator and then a system for, there's a link to the paper, a system for monitoring its performance, and how a traditional learning algorithm, oh yeah, it's mentioned in the post, exactly. So a traditional machine learning algorithm had a certain level of performance, but when he sort of superimposed a systems theoretic framework on top of the algorithm, it improved the performance of the algorithm. And this is like what most of his work is focused on. He uses something called Mesarovichian systems theory, which is one approach to formal definition of systems. And I'm curious, George or Daniel, have you heard of this Mesarovichian systems theory at all?
I don't recognize that name. How do you spell that?
Yeah, it's MESA, posting in the chat, MESAROVICIAN. I was looking a bit at
Mesarovic? Mesarovic? Mesarovic?
Yes.
All right. The name is familiar. Oh gosh.
Yeah, I never heard the name, but I was doing some digging and it looks like he has been very active in the systems community since the early days. And he's proposed a formal mathematical definition of a system. So I'm wondering if Tyler could use that framework for this type of work. Would he also be interested in / capable of adopting your mathematical framework and seeing, you know, how it compares?
Oh, wow. Well, this looks certainly like what many people already do, but also I didn't know this last name.
Mm-hmm.
But this is a very transferable approach.
Mm-hmm.
And this looks exactly like the category theoretic dynamical systems CAD models that are existing now.
Okay.
And I mean,
speaking of which, it just happens, coincidence. I'm going back over Robert Rosen's Life Itself book.
Oh,
and speaking of category theory and block diagrams and strict formalism for systems definition, in my books I didn't really pursue that too deeply. I give Rosen credit for well, particularly the anticipatory systems notions, but I didn't want to scare too many people off with. For me, category theory is extremely abstract relative to sort of the practical aspects of capturing system knowledge and so forth, and using set theory and graph theory and so on. But if you look very carefully at the structures that I've created, you'd probably get a glimpse of category theory being part of that. And like I say, it reflects it. If you want to go hard nose into it, Rosen is a pretty good place to start.
Yeah, it's
But
amazing how
yeah, I do recognize the name now, and I can't, but I'm having trouble pinning down the specifics.
I mean, and then also even the four pieces here map to the partition in active inference: cognitive system,
Yeah.
action, world model, perception.
Wow.
Yeah, it's all coming together, guys.
But how? I
Ask
mean,
ChatGPT.
yeah, exactly. Yeah. I mean, what do we even really have here? We have the Meserovic. This is the Meserovican. I hope this person forgives our pronunciations. The Meserovician general systems model. We have the Robert Rosen closure anticipatory systems approach. There's what's written in George's book. There's active inference type modeling. There's CAD-CAD. Active inference and CAD-CAD, we've already made some of the connections, but not all of them. And then, I mean, one question that always comes to mind is like, how does this go beyond concordance hunting? How do we really make a useful juxtaposition where we can align things and find out where there's like functionalities that are offered by one framework, or questions that have been like arisen or addressed in one framework that transfers, so that it's not just like, oh, well, this is like that. That's one question. And then the other question is like, to what extent to engage in kind of like a pairwise, is not exhaustive alternatives, but like a pairwise concordance journey, like versus a top down mapping, or maybe we use the principles of systems and first just complete like a matrix or something with the principles versus these kind of partitioning systems, and then understand how each of these partitioning approaches capture or implement those systems properties. Just I mean, to like from the get-go establish system science as the framework for studying these proposals.
Well, if I might offer it,
yeah,
and I've felt this for a very long time now, but we are on the verge of a grand synthesis. We've got so many different threads there. We still have the problem of alternative languages, but I think if we focused on the semantics of those terms and phrases and so forth, but everywhere I look, I see fundamentally the same things in terms of defining and coming to grips with what does it mean to be a system. And boy, I think it would just be grand if the ISSS or members of the ISSS could form a task force to tackle that. We have all the rich resources of the ISSS plus the systems community at large. And people have been talking about this idea of what do we mean by a systems theory? And there have been all sorts of personalities who've insisted their theory is the theory, so forth. But if people can approach this with an open mind and a conviction, and that's what it's going to take, is some conviction that all of this can be integrated and synthesized into a theory, a common theory. I think certainly from my perspective, as long as there's some sort of a minute thread back and recognition of my contributions, I'll be happy. I don't think I've found the theory, but I'm pretty convinced I have this vision of a theory existing that we can, but it's going to take a younger, newer group, hint, 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 of people tackling that. And I wouldn't even necessarily, I would go back to the sources, you know, and but take it on as your own project. Don't go to people like me and go to people. I mean, in person. I'm talking about, but go to the body of work that exists and start to try to synthesize. And the reason I'm somewhat passionate about this is that's what I think I was trying to do particularly in the newer book, is trying to look at all of the different things that I was aware of and bring those together and try to synthesize them. And so give credit where possible, but also recognize that when you start to put things together as you know, take so supposedly disparate ideas and put them together in a synthesis, that it's not going to be possible to say that's due to so and so. That's, you know, this is due to so and so. This is something new. And you can, you know, bibliography, you can list all your sources, but don't try to necessarily cite specific people for specific ideas in accomplishing that synthesis. So I didn't succeed terribly, and I got dinged a lot of times for not giving adequate citation. But I think that's kind of what it's going to take to do. In any case, I think overall, the knowledge base that's out there now, whether any of us has adequate access to where it all exists and how it all fits together, it's there, and it's ripe for someone to start producing a synthesis.
Yeah, that's awesome. I mean, it's definitely something that motivates my work. And I wonder about how some of these new ways that we're approaching the knowledge engineering, like, it may make a lot of this scholarship, it will facilitate a lot of this scholarship. Not just the automated reference management, but having access to the full text, being able to find rather than like having it digitally rather than on text, obviously is transformative. Now we're continuing to take steps in the ability to synthesize texts that can also be used to improve our awareness of system science. We would develop many interesting methods along the way. If we believe that there's an elephant in the room, and we then take a very broad view on what have been perspectives on it, and use a somewhat, just beginning with a somewhat more plastic categorization, but starting with the principles. The things that many people emphasize, like the hobby horse / axe to grind, are often literally just perspectives on the system's principles. That, like, some feature about systems has not been accounted for properly in somebody's mind. And so while that may be their contribution to a given project or group in a moment, having a better structured way to convey that that's not necessarily a novelty to the field. It would be like a chemist reminding people about pH mattering for reactions. And then someone else is like, well, the salt ion concentration matters. And someone's like, and the pH matters. It's like, okay, we agree. And here's the chemistry textbook. I mean, how can we how can we continue? I see a few angles, of course, other than just getting more people / attention on it, to structure and decompose the textbook, basically, which I've done in other cases, starting with the outline, tables, figures, bullet points, and so on, but decompose the textbook so that and embed it within a relational structure, initially like a coda, and then utilize, and then on another track develop the flows that will like bring in larger corpuses or like inference abilities beyond just relational abilities. But yeah, how can we proceed with this on the research side while also keeping the shallow ramp of education so that people can join up on the path?
Well, I sort of envisioned the two textbooks that I worked on as being like skeletons, initial or prototypes or something like that. That basically they're not trying to represent that this is a complete view. The main idea behind them is that they try to bring all of the various ideas of systemsness into one package and give a hint of, like the knowledge-based structure, for example. That's just a pointer to a possible solution to knowledge engineering. But it might be reasonable to think of it as just kind of a starting hypothesis, and then try to take parts of it. When you said parse out the book, I assume you meant that. But take those pieces and say, all right, what did so-and-so have to say? Or what did this body of literature have to say about this? How do we fit it in? How do we make it more complete? Things of that nature.
Yeah, like versioning. I mean, having the book in a more of a Git-like structure so that pieces can be versioned, and then there could be mainline textbook, which can always be recomposed and initially just like recapitulating, but imagine versioning. I'm just speaking openly about, in a totally permissioned way. And then also a given section could have sequences of prompts that can make a 1-sentence summary of this, or expand this into an outline for a dissertation for a given section. But the main line, where potentially even we don't wrap in generated text at all, can be, or where it's not possible to do that kind of like total copying, yeah, just distill. That's what I was referencing, like a given table or a given section subheaders, and just extracting that information and then versioning and building that structure. I mean, and just like any other textbook should, that is the educational path. The first grade chemistry textbook is elaborated upon later, but it introduces the background concepts and maybe even some of the core concepts of chemistry. So then even knowing what, I mean, maybe the educational path is structured around the core principles and just like spirals of learning on those principles. Or maybe another mode is system of interest, and then kind of like rows and columns, and that's going more across aspects of a given system. But we need to be able to pull back to be able to see like the rows and the columns, like going across systems on one principle and across principles on one system. We need to see that in an integrated way that doesn't have people saying, talking at odds with each other when it's the same underlying fabric that we're wanting to be studying scientifically. What do you think, Carl?
Yeah, I was just thinking, well, I'll start getting some bandwidth back again here in June, and things, and basically like my doctoral research and things. Well, you participated in one of them, but we've kind of got a process that we're developing within my university that's like an hour long, and we can kind of go through our dissertation, like where we are as far as our dissertation goes. And I've got very strong connections with systems, and actually with Doug Engelbart being one of my core people. There's networking improvement communities as one of my components and stuff, and I see ISSS as being one of my core improvement communities. So it's about a group that's systematically trying to improve the improvement process, kind of thing. But I was just thinking that as I develop my approach a little bit more, I could almost be a case study, but we could find a way to get some feedback from ISSS, and then reach out to all the people who are working on their PhD and where are the connection points and things, because we're doing that research anyway. So how can we do things so that that doctoral research work, and that can also be a way to reach out to some of the to younger people, to get them connected with to ISSS. So because that's another piece of it. So I think there's something there, basically. As I'm going forward, kind of thinking of myself as a case study about how I, as a doctoral student, can be supporting ISSS.
Thanks. Yes. Definitely agree that having obviously there's nothing magical about any credential or enrollment in any program, but having somebody who is a PhD student who is going to be like seeing this synergize with their work either way would be just extremely, extremely helpful. And also just to have that be like aligned with their broader impacts, or any kind of other broader participation that they want to engage in, if like a systems or complexity type group doesn't exist at their university. And essentially broadly they don't. So
right. And then another connection point that really can get into the mentoring and things too is I'll have an external reader as part of my committee. It has to be a PhD with no affiliation with fielding and stuff. So there's all kinds of possibilities for ISSS members to be external readers for dissertations, and that build that mentoring relationship, the one-on-one mentoring relationships.
Yes. External thesis committee member. Yeah, and like I don't know if the external thesis reader needs to be in an academic senate position. I just don't know. But many people are. And so then ISSS would just help route that connection to somebody who is qualified to do that reading.
Yeah.
And then that could be, it could be encouraged that would be like, you don't just call that person 2 weeks before your dissertation's due.
Yeah. So
you reach out years earlier. Yeah.
Right. For the requirements are somebody with a terminal degree that doesn't have any affiliation with the university.
So they don't even need to be.
I don't know how other universities are, but that's what mine is.
But they don't need to be necessarily a professor or something.
Or JD.
Well, we have doctoral thesis committees, and we have from time to time had people who were in industry. They didn't have a academic position. They were just in industry, but they served on the committee. So I think that'd be like a reader that Carl's talking about.
Yeah, this is a very good suggestion. I mean, it always just relates to how clear can we make the opportunity, and then what are people's bandwidth, and how can we convey that like both people are going to bring something to the table, and communicate that to PhD students who are just basically starting. Okay. Let's review some of the things that we've worked on / towards. We've asked, I guess, what education group can do for an ISSS series. At least put it out there, but we haven't necessarily done a specific request, largely because it's not like we have some, allocatable personnel or anything like that. Early on, someone suggested this: pub talking points, everyday memes and themes. These are like just core educational content, but maybe delivered in a more informal fashion. And the discussion around the how to use these Carl sent this. Okay, cool. How to use the interface. I think we can revisit this as we develop it out a little more with Rob. Standards in system education didn't really proceed along. I mean, there are several paths there. One thought would be when we have some kind of distillation of the textbooks, that then that could be that the I mean, the systems science theory should establish the educational curriculum and the standards for learning that theory. We're drafting some levels of qualification at Active Institute. It's been very interesting to like to think about what those levels of qualification should be, and we have like knowledge alongside skills and like responsibilities. So it's not just like what one knows, it's also more action based, but also returning leader. Curriculum, I mean, we can always communicate to our to the people who have expressed interest over the last, you know, almost a year or so, and try to connect with them and see who wants to contribute on these things. But seems like we're only indirectly developing the curriculum at this point, although arguably the Substack work is curriculum development. At least it motivates it, if not directly providing a path. But this is a huge topic. This is sort of the Shingai and George angle, and Carl, so it's good to see that all of you have continued. System census, we only pushed it one time, got 10 responses. George, we never met with Wayne.
I did hear from Marty, what's his last name? Martin Zwick.
Okay.
He basically indicated, he didn't tell me exactly what, but he indicated that they're still having issues with keeping that program alive. So I'm not sure we're going to hear back from Wayne.
So then, yeah, I wonder what programs at that point.
Well, I'm going to answer Marty's email shortly, and I'll ask him if he can elaborate.
Sounds good. At some point, writing a summary, although I mean, I will just for now just delete this. Like we're not needing to update people on it. Then this is more of just a task to help educate on Coda use. I mean, I in a few settings I've wanted to make this, so I just kind of need to specify it and make it. But also but there's, if you do /learn, it does take people to a professionally designed learning hub. So I'm a little bit like unsure about how I specifically want to do this versus just letting Coda's kind of tools. Yeah. So I mean, thank you, Carl. Let's continue to revisit this type of synthesis work, because I think it's kind of like to create standards or curriculum without a better sense of the topic itself is probably not, it's probably a little cart before the horse. Any other thoughts on this?
One way to characterize this, Daniel, might be that the role of the ISSS is to educate the world about systems, and the role of the committee is to implement that, and so proceeding along the lines of synthesis as a basis for any kind of future standardization would be really right in line with our reason for being.
Perfectly said. Yeah, that totally makes sense. So in the times between, let's think about this. In knowledge engineering, I can also bring it up and see what people think. And then otherwise, let's get to the good stuff. Keep the other things kind of just latent, and maybe then prepare more of a research analysis synthesis group, and see that as like the big work that many other initiatives will flow out of. In some ways, just reflecting on my earliest kind of actions, which were to ask around and all the members and social media and stuff, like what are people interested in and what do they think could, in all of these different areas. And they are perspectives on system science theory and application. But I mean, it really does seem like the deficit of synthesis is what leads to these solutions just being unable to have the impact that people want or expect them to have. Because like, okay, a symposia on what? A training on what? Platforms of what? All of that, it matters what the topic actually is. And so that's kind of the water that we want to swim in, but it's a dry ocean if we just have disaggregated personalities.
Heartily agree.
Yeah.
Well said.
All right. Any last thoughts, Shingai?
Yeah, I did have a couple of questions come up for me during this discussion. I'm wondering if this situation in the system science community where there seems to be a lot of friction around this goal of developing a common unified theory, is this sort of dynamic pretty typical in the sciences and in scientific history? Like, does this sort of thing happen a lot? Are these sorts of politics just human nature, or is there something unique about this topic that is exacerbating it?
Well, I think it's human nature. I mean, look, in the field of neuropsychology and consciousness studies and things like that, we've got multiple theories that have been developed sort of along independent lines, except that you can now begin to see that they are converging on various aspects. So, and you've got personalities who are involved in developing those theories or theoretical frameworks, and so that happens. I've seen it in evolution theory, for example, in systems ecology. Not because it's systems, but because different people have different perspectives on what counts as ecological studies. So I think it's, but the thing about science is you do empirical work and test your hypotheses, and eventually you begin to converge on a consensus in the field, the so-called paradigm. So I don't think that's unusual. What is different is that in system science, we really don't do that kind of empirical work. It's mostly, since I believe it is a meta science, it's mostly a matter of developing grand model schemes, if you will, and then seeing where there's overlap, as opposed to being able to test a theory per se. My recent interest in what I've called ontogenesis, and Tyler Volk has called combogenesis, and Len Troncalli has, I forget what he calls it, but basically these are areas that can be a little more empirical, in the sense of we can develop hypotheses about the process. So we're talking about a specific process of becoming. Develop hypotheses about the processes, and then go look at specific systems to see if we can identify those the process working in those systems. So it's not a matter of just saying, oh, okay, here's a block diagram. This is what a system is, and it's got inputs and outputs. That's almost a given kind of thing. But what we're talking about is, where did systemness come from in the universe as a whole? And that gives you something that can be handled, I think, in a more scientific, more traditional scientific way. And then you start to develop, did you prove or disprove, rather? Did you disprove your hypothesis, or how do you modify it? And eventually we come along toward a consensus, I think. So it's not abnormal, but what I'm suggesting in this synthesis I'm talking about is put together a team of people who are dedicated to actually finding the reality behind all of the different theories that are out there now. Don't ask people. Don't ask me. Don't ask Jamie Rose. Don't ask Len Troncalli. Take their work, look at it, see if you can see the patterns that are overlapping and worthy of integration and synthesis. So that's why I want to see some new minds, some new younger blood involved in this, because us old guys, we're just going to stand and say, no, this is the way I see it, and that's the way it is. And we don't need that.
Yeah, absolutely. Thank you. I feel in some ways it's comforting to know that it's a human nature problem in general. For some reason, I find it comforting. And I guess a question is, for both of you, is it like within our scope of this group, what we're working on, to sort of identify what is like a minimum viable testable hypothesis? So that is like a core goal we're working towards. Like, how do we arrive at a hypothesis about this stuff that we can test and get empirical data on? Is that one way of looking at what we're doing?
Yeah. Well, like I say, I've been focusing mostly on the process of ontogenesis, because that is something that you can actually. This is kind of what Troncalli was doing. He was doing it by counting papers on a subject that were published in Science and Nature and other journals, and just counting the number of papers. I think that's a good sort of starting point to see how much of this is out there. but it's not exactly the same as um, producing a hypothesis about mechanisms and processes, and then taking those papers and the subjects that they're about and seeing whether or not that's actually working. So for example, I mean, I've been really interested in the origin of life problem. Len Troncalli was interested in the transition to nucleated cells, eukaryotes. And so he was looking at those processes a little more specifically. And then also in the area of cognition, how the brain works, and you know, to me, there's a systems approach to understanding the balance between, well, the active inference notion identifies the fact that the brain is actually projecting expectations, and then the actual perception is confirming or disconfirming. If it disconfirms, then the brain's got to do more work to try to figure out what that difference is. So those are real ways of looking at. We might not have sufficient instrumentation right now to look into what's going on in the human brain anyway. But that's the sense in which I'm talking about, that these are things that we can actually do real science on, really come up with working hypotheses, and then try to identify experimental approaches or observational approaches to determining the veracity or not of those hypotheses. And so that's normal science.
Yeah.
We're
Yeah,
scientists
Daniel.
too, you know.
Yeah.
Yeah, Daniel, any final thoughts on any of this? I feel like I could use
Oh,
call at some
yeah.
point.
Oh, there's
Like,
just a lot to think about, but let's digest it and come back in 2 weeks.
Okay, that sounds great. All
All
right.
righty.
All right. Thank you. Farewell.
Thank you
Bye.
too. Bye-bye.